Number 1 should have gotten D6, 5. So your whole midpoint packet was based around one question. Good job. All right, transformations. You should have gotten F, -4, -2, 2, -4, 3, 1, -3, 2. This is a great example of not wasting your time with the other 3. If you see that you got the right answer for the first coordinate, move on, right? Because they're all the A's are unique, or at least all the first coordinates are unique. So anyway, we can come back to that, but anyway. All right, volume. This probably all could have been called volume, since there's probably more volume questions on here than most anything else. Volume number 1 is F, 36 pi. 2 is J, 2 to the 9th. I think that's a repeat question. You guys have seen that on a different packet. Number 3 is a really good question, and probably one that we want to cover if you missed it, but we'll cover it when we get through this. J, 30,000. Okay. Inductive reasoning, number 1. This is one that's commonly, and I'll explain that probably whenever we get to that. G, 61. 2 actually has a formula to it, so that'll simplify life if we know that. 2 is D, 9. Then we get to similar figures, which probably is going to be some questions we've already seen. Number 1, I think, is a repeat. A, 3. Okay, I know 2 is a repeat. We should have gotten E, 2/3. 3 is A, 5 3/5. 4 is A, 10. 5 is G, 6. 6, hopefully you were able to get this right even with the typo in it. There's a typo in the formula there. But you should have gotten K, 8. Last page, 7 should have been F, X over Y. 8 is G, 12. And 9 is K, 12.5. Does anything need to be repeated? Okay. Number 1. Does anybody need number 1 done up for them? Anybody need the midpoint formula? No? Okay. If not, we'll move on. Oh. All right. No, let's see. Transformations, number 1. Anybody need to see how to work that out? No? Okay. 3. Let's see. 1 through 3. Yeah. Which ones? 3. Anybody besides 3? 1. Okay. Let's do 1 here real quick. It says volume of a sphere is determined by the formula volume equals 4. It's really 4/3 pi r cubed. You can do it 4 pi r cubed over 3, where r is the radius of the sphere. What is the volume in cubic centimeters of a sphere with a, notice it says diameter of 6. So I'm guessing that's where our mistake is. So you want to rewrite that as, 4/3 pi 3 cubed. Okay, and try that. So you're pretty much doing, because it's in terms of pi, you can work around the pi. So 3 to the 3rd is 27. 27 times 4 divided by 3. 27 times 4 divided by 3 comes out to 36 pi. Okay? Okay. Yeah. Number 2 was J, 2 to the 9th. Do you want to see that? Okay. All right. We've got a cube with an area, with one side with an area of 64 inches. So, if I draw a cube, okay, what is the volume of the cube in cubic inches based around 2? So if they're telling me that the area of one side is 64, okay, well, all sides of a square, right, are equal to each other. So the first thing I'm going to do is find the square root of 64, and I should find out that that's 8. So I'm going to get 8 here and 8 there, okay, but I'm also going to get 8 there. So I'm going to find the volume. Well, volume is 8 cubed. Well, what is 8 cubed? 512, right? But I don't see 512 up there. So what I'm going to do is I'm going to break that down into primes. And really 2 is going to work out the best for that. So I'm going to get 2 and 256. That's 2, and it's going to break that down to 128. 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm finding that 2 to the 9th is the same as 512 cubic inches. Okay? All right. There is another way to do this, it might be quicker, is taking 8 and breaking it down as 2 to a power of. So 8 is 2 to the power of 3, and then we're cubing that. And so I can just do that as well, okay, where I'm multiplying those exponents, which is quicker, but if you don't automatically see that, you can still take 512 and break it. Okay, now to number 3, which most of us had a question on, right? Okay, so because we want to find the volume of something that has kind of a strange shape. Now, I think that there's probably more than one way to do this, okay? Because what shape is this? Because it's a prism, right? Essentially, it's a prism. If we want to find the volume of a prism, we take area of the base polygon times the height, or in this case, the depth. There are really 2 ways to do this. The way that I had always done this up to now, make this a rectangle, and then subtract out. Okay, so find the volume of the rectangular prism and subtract out the volume of the triangular prism, right? Okay, but the nice thing about this, and so we could do that. Let's go ahead and do that. So what I'm getting is, notice that it's like 50 feet in depth. So I know I've got 50 feet out here. Okay, so that's going to be, I've got 10 by 75 by 50, right? So I'm going to take 10 times 75 times 50, 10 times 75 times 50. I'm getting 37,500 feet cubed. Okay, does that make sense? And then I'm taking the area of the triangle times the depth. So if this is 4, this, and that's 10, this has a height of 6. If that's 25, then this is 50, right? So base times height. So 50 times 6 divided by 2. Okay, I get 150 is the area of the base triangle times the depth, which is 150. Okay, it comes out to 22,500. So I'm going to subtract that. If I've got that right. Now, and I don't think I do. I should get something like 7,500. Oh, yeah, I multiplied by 150. So it's 150 times 50. That's where my mistake was. So 7,500. Okay. Yeah. So minus 7,500 is leaving me with 30,000. I want to try a different way. okay, even though this would give me my answer. What shape is that? Anybody tell me what shape that is? It's not, well, yeah, it's a it's a trapezoid. Well, I guess it doesn't really count as a trapezoid, does it? Because it's got 5 sides. I was going to say, if we could count that as a trapezoid, then we could have found it. And I think this way you really do actually have to take the rectangular prism and subtract out the triangular prism. Okay, so does that make sense a little bit more to us? Okay, subtract out what we don't need. Okay, let's see. Now we get into inductive reasoning. 1 and 2. 1, 1. Okay. All right, let me explain, because I think I know what a lot of you did. How many of you got 80? Probably a lot of you, right? Okay. So what you saw is 1, 2, 3, 4 times 20, correct? Here's the problem with that. Okay, so let's say I count 1, 2, 3, 4, and then I go to this guy, 1, 2, 3, 4. Do you see a problem yet? Yeah. I counted one side twice, right? So the best I can actually do is 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, until I get here, in which case I have 1, 2, 3, 4. All right, so what I'm actually doing is 3 times 19 plus 4. Okay, well, what's 3 times 19 plus 4? 61. Okay, so, don't just look at it and make a quick assumption. Try to test it real quick, right? If I'm overlapping, I probably have done something wrong. So we need to actually work a system out in which I'm not overlapping. I'm using every one, but not every one of them twice. All right. Otherwise, what I have to do is take, 4 times 20 minus 19 of my overlaps. All right, number 2. Okay, so you could do this. Well, let me clear that up. Okay, you could do this by actually drawing lines, right? I've got a diagonal here, diagonal there, that's 3. And I need unique diagonals, right? So 1, 2, 3. I could pick a different color. Now I'm trying to find ones that aren't already matched up. Basically there. I might be able to find another one here, those types of things. But in the end, it's getting really confusing to count and see which ones I haven't already counted. You know what I mean? So you find yourself drawing and then erasing and starting over again and trying to do a better job of counting. Well, there's a better way than that, which is take the number of sides that you have times the number of sides you have minus 3 and divide by 2. So how many sides do I have? I've got 6 sides, right? So 6 times 6 minus 3 divided by 2. Well, 6 minus 3 is 3. 6 times 3 is 18. 18 divided by 2 is 9. Okay? So that formula will tell you the number of diagonals. Okay? So not a bad formula to hold on to, because you will see questions like this. Okay? Otherwise, you're left drawing and counting and hoping that you've got it. All right. We'll get into some repeats, but that doesn't mean that you don't have questions or need a reminder on something. So by all means, ask if you need to ask. Number 1. Okay. Number 2. Yeah? Okay. This one, to me, I don't even go to the similar triangles portion of things or whatever, I think similar figures. I just go straight to that. FD is a segment, okay? AD is a segment. I'm looking at what fraction of AD is FD, right? It's over half, correct? So half is greater than a third, correct? It's not 1/2. If I take and I figure out what radical 3 is, I want to say it's like 1.7, something like that. I don't remember exactly. figure out for me what radical 3 is. Or maybe it's 2.65. Well, we know that we're over that. Okay. We know we're not 1-to-1. All right. If something is 1-to-1, then it's exactly to scale, right? If you wanted to make you ever see like, I just saw a video recently where somebody with Legos made a 1-to-1 scale of the new Chevy Silverado, right? Which means it should be exactly the same size, right? Well, clearly AD and FD are not the same, leaving me with 2/3. Does FD look like it's 2/3? Okay, so that's as far as I go with it, right? So rather than getting caught up in similar figures, okay, I just go that route. 3, okay. Thought 3 might come up. Let's see if I can do a good job with this. All right, let's see. In the figure below, AE intersects BD at C. AB is parallel to DE. That's important because if I have 2 parallel lines, then what I have is anything that crosses those parallel lines is a transversal, which means alternate interior angles are congruent. Okay, same way over here. And I also have vertical angles there and there. So I know that the triangles are similar. If I have similar figures, then I know that they're proportional. Their side lengths are proportional. So this 5 corresponds to that 4. So I got 5 to 4. You follow me so far? They're wanting to find out what is CD. So I need to find out what corresponds to CD, and it should be this length right here. Should be that 7. Okay, so because 5 is on top, I'm going to put 7 on top, and I'm going to cross multiply and divide. So 4 times 7 is 28. 28 divided by 5. 28 divided by 5, or sorry, 28 divided by 5. Well, 28, there's a 5 will go into 28 5 times with 3 left over, leaving me with 5 3/5. Okay? What about 4? Anybody on 4? 5? 5, we got several 5. In the figure below, A lies on CQ, P lies on QP, AP is parallel to CB. If AP is 5 units long, okay, PQ is 3 units long, and CB is 15 units long, how many units long is PB? We want to find that, okay? All right. So we have to understand similar figures in that we are comparing this triangle to this triangle. A lot of people end up making out a trapezoid. We can't do that. Okay, so they are proportional because they share Q, and we know that if we have AP parallel to CB, okay, which they tell me, then I have those corresponding angles, right? Okay, so if I set this up, I'm doing 5 over 15, but I'm not doing 3 over x. Did you do 3 over x? Okay, this is not the entire length of that side. Okay, if I'm going to do 3, I have to do 3 over 3 plus x. Okay, because QB, or, is that entire side. Okay, so I'm going to cross multiply from here. I have 45 equals 15 plus 5x. And all this is going to do is solve for x. I'm going to have to, well, yeah, it's going to solve for x, but I want to know what PB is, but that's what we want, right? So minus 15. All right, so I've got 30 equals 5x. X should equal 6. Okay, and as I get to the bottom right-hand corner of my screen, it gets really iffy. Okay, does that answer that for you? Okay. Common mistake there. Okay, 6. Yep. Okay, so there is kind of a quick way to do this. There's a quick way and there's a long way. Okay, notice that they tell me that there are 3 containers. There's one that's 1 radius. I got my second radius, my 4 radius. I want to know, let's see, okay. How many fillings in the middle-sized container would be equivalent to 1 filling of the largest container? So I'm actually not even concerned with that one at all, right? I'm not concerned with the smallest one. All right, so we could go the long route, and in the long route, we're doing 4/3 pi 2 cubed, right? And we're going to solve that. So we've got 8 times 4 divided by 3. Okay, 8 times 4 divided by 3 comes out to 10 2/3, right? Okay, something like that. And then I've got my longer one, which is, or 4/3 pi 4 cubed. Okay, so we got 4 to the third, which is 64 times 4 divided by 3, which is 85 1/3. All right, and then I have to take 85 1/3 and divide it by 10 2/3, which is kind of a pain, right? This is what I want you to understand. Okay, look at the relationship between 2 and 4. 4 is twice as big as 2, correct? Okay, so if I take a 2-dimensional figure, okay, the perimeter and the scale factor stay the same. But if I look at the comparison of areas, if I double the length, right, if I double the scale factor, the area will square. Okay? So if I'm doubling the radius, but I'm comparing it to volume, I'm cubing it. All right, so I'm always taking it to another exponent. So because this has a difference, I'm doubling it, right? Okay, we're taking that, and it should be, 2 cubed equals 8, so we're 8 times bigger. If we take 10 2/3 times 8, we should get 85 1/3. Okay, does that make more sense? Okay. Okay, let's see, last page, 7, 8, and 9. 7, 8, 8. Okay, television screen sizes are the diagonal length of a rectangular screen. Hector recently changed from watching a television with a 13-inch screen to a television with a similar 19-inch screen. If a boxcar appeared 8 inches long on the 13-inch screen, how long to the nearest inch will it appear on a 19-inch screen? So what we're doing is let's compare 13 to 19. Okay, it's going to be the same ratio as 8 over x. Okay, cross multiply and divide 19 times 8 divided by 13. You're going to get 13x equals 152. You're going to end up with 11.69, but because it says to the nearest inch, we're going to say 12. Okay. All right, what about 9? 9? Nobody? Nothing? We're done? Great.